Okay, so I just got the confirmation, so I'll start. So once again, good evening everyone. Myself Dr. Rijul Agarwal. I'm the orthodontic faculty at DAMS. So as I told you, it's a two-part lecture. The last part we covered in the previous lecture of the basics about orthodontic biomechanics. Today we'll be discussing about the application of biomechanics in the field of orthodontics. Okay. So once again, good evening and welcome to all. So before starting, a quick revision or a summary of what we did. So as we discussed last time, this location or definitions of center of resistance, center of just a minute. Yeah, this will be fine. So as we discussed last time, the definition of center of resistance, center of rotation and all. So today we'll be discussing its application. So before beginning, a quick revision. So last time we studied the location, type of tooth movement and the variation in the location of center of rotation. So for translation, it is at infinity. Infinity is not a predetermined point. It's a point which is located very far away. So it's believed that a body rotates around that imaginary point which is located quite far away. Next comes control tipping. In control tipping, the root stays there, the crown moves. So the center of rotation is at the root apex. Next comes uncontrolled tipping, in which the root moves in one direction and the crown in other direction. So the center of resistance is located apical to and very close to the center of resistance. That is the center of rotation, is located apical to and close to the center of resistance. Pure rotation, the center of rotation coincides with the center of resistance, and in torquing, that is basically root movement. It is located at the incisor edge. So what kind of question does your exam comes up with? One type is directly they'll ask you where is the center of rotation for such kind of movement. Next is this kind of question, that is a loading diagram of bodily movement is triangle, circle, rectangle or square. So what does it mean? So for tipping, as I told you, there is application of force at the crown level. The root moves in one direction and the crown moves in other direction. So what happens is there is areas of compression and tension which are generated. So now the question is asking about the loading diagram or the point at which the force is applied. So for tipping, the loading diagram is triangle in shape. It is triangular in shape because of half areas of compression located in the region of periodontal ligament. Now for bodily movement, since the area of compression is located on one side only due to bodily translation of the tooth, so the diagram is rectangular in shape. So it is rectangle in shape, triangle for tipping movement. Okay, and subsequently for intrusion, since the area of compression is located at the tip or the root apex, it is in the form of a ellipsoid shape. This is how further the examiner can ask in your exam. Okay. Sorry. Just a minute. Next comes the types of force system. So there are two types of force system. One is determinate and next is indeterminate. What do I mean by determinate and indeterminate force system? If we go at literal translation or the English translation of these words, determinate means the force system which can be determined, or you can quantify the points at which it is applied. Okay, indeterminate is a system which is complex and the force system cannot be measured. You cannot measure this force system. Okay, so in auto robotics most of the force systems are indeterminate. How? When we place a wire inside a bracket, it has a multiple points of contact on the surface of the bracket, so you cannot determine what kind of force is being exerted at what point. So we consider it mostly an indeterminate force system, but still we can have indeterminate systems as well in here. How and how is the force system indeterminate? We'll just see. So the example of determinate force system is a one couple system and indeterminate is a two couple system. So what is a one couple force system? So one couple force system is established between two attachments when a couple is created one end an attachment and a single force is created another, also known as a one bracket force system. So in this, the wire is inserted inside one slot like this and it is loosely ligated or just touching or lightly placed, or you can say placed as well. These are the common words which are used to describe the engagement of the wire inside the other bracket slot. Okay, so it involves a wire with a bend which is inserted in a bracket or tube, while at the other end it is just tied to the attachment so that only one point of contact is created, and that one point of contact exists because of this only. Okay, so the example is of this one couple system is the cantilever spring or auxiliary arch wire placed into a bracket or a tube. Sir, no audio. Just a minute, I got the confirmation the audio is fine. Just a minute. हाँ जी, हेलो. हाँ जी, हाँ जी, हाँ जी. I have got a confirmation that there is no audio problem. So Mohammed Ali, you have to rejoin back. If anyone else facing the audio problem, just write in the comment section, because from their end they are saying it's fine. Okay, I'll proceed forward. If anyone else facing the same issue, just write in the comment section about audio. Okay, so I'll just repeat one couple system in which a wire is inserted in a bracket or tube, or at the other end it's just tied to the attachment so that only one point of contact is created. Okay, it's fine. So Muhammad Ali, you just have to rejoin back. Maybe it will work again. Okay, So its example of this is a cantilever spring or auxiliary arch wire placed into a bracket or a tube. So next comes a two couples force system. As I told you, it's very easy to describe. When we just insert or tie the bracket completely, wire tied completely or engaged, these are the words which are used, into the bracket slots of two bracket slots or a two bracket slot or a tube. So it's a two couple or a indeterminate force system, also known as statically indeterminate system. So in this kind of two couple force system, we can have two kinds of wires bends can be placed. One sorry, one is a step bend, another are V bends. So what are step and what are V bends? First of all, these two all come in the indeterminate force system now. Okay, so in indeterminate we cannot determine what kind of force is being exerted at what point. What we get is a net result in this system. Okay, so what is step bend, what is V bend? So as I told you, in between two brackets we can have either a step bend or a V bend. So now the V bend can be symmetric or asymmetric in nature. Symmetric V bends will be the one in which the tip of the V is between the two teeth, that is at equal distance. And asymmetric will be the tip is not at the center, it is at some distance or closer to one tooth as compared to other. So it will exert different kinds of force system and create different kind of movement on each of the different teeth. Okay, so what is a step bend? The step bends are the ones which create two couples in the same direction regardless of its location between the brackets. Okay, so this is an image of a step bend wire which is placed between the bracket slot. So what, for your exam point of view, what you need to know is the movement which is generated and the movement which occurs. These are two different terms which you need to know. Movement and movement. What kind of movement will occur? Movement will be either extrusion or intrusion. Okay, and movement will be the result of the couple force being generated. Okay, so in step bend it generates two couples in the same direction regardless of its location between the bracket. So supposedly this is a step bend which is placed between these two teeth. It will generate couple in the same direction. Okay, and as we know from our previous lecture regarding the law of Newton's law, the movement will be in the opposite direction to balance out this couple. So it will be like this. Okay, so one tooth will intrude, one tooth will extrude. Okay, so for your exam point of view, what you need to remember is that it creates two couples in the same direction. Okay, so this was the easier part. Next comes the symmetric V bends. In symmetric V bends, what will happen? The tip of the V is between the two teeth at an equal distance. So it will create equal and opposite couples on each bracket which will cancel out each other. Since these couples are cancelling out each other, no net movement will be present, and as a result, since there is no net movement, there will be no movement which will occur. So everything will balance out each other. Okay, so this is the symmetric V bend. In asymmetric V bend, which is important and from where most of your questions of application based questions comes in your exam, the tip of the V is nearer towards one tooth as compared to the other. So what happens? जिसके दांत के पास ज़्यादा टिप होगा, this V का end, वहाँ पर movement will be more. So in this image, example for this image, the movement generated will be more on this teeth as compared to this teeth. If we take this as teeth 1 and teeth 2 will have more movement. So the net effect of this movement will be like this, which will have like this. And as we know, according to law of equilibrium, Newton's law, the net, what will happen, the body will try to balance or counter this movement. So a reverse movement will be generated in this direction. So what will happen? The movement is on more on tooth 2 as compared to tooth 1, but the movement will be, that is movement, will be according to the counter movement which is generated to balance this out, this movement. So it will result in intrusion of tooth 1. Tooth 1 will intrude and tooth 2 will extrude. So this is the result of asymmetric V bend placed in between two bracket slots. Okay, so I hope this is clear. This is very important for your exam. This A is concept of asymmetric V bend. Most of the application based questions comes from this topic. The location of the tip of the V, located near to which tooth, and what will be the result, net movement generated and counter movement किस direction में generate होगा, and its effect. If anyone has doubt, please write in the comment section, otherwise I'll move ahead. Okay, next important concept or important thing which comes from your biomechanics is the types of intrusion. Okay, so one is, there are 4 types of intrusion. First is the true or absolute intrusion of the teeth. So it is achieved by moving the root apices of the anterior with closer to the bony bases. Simple. To correct, why we do intrusion? To correct the deep bite or the increased overbite. So for that we need to intrude the lower anterior teeth so as to open the bite. So simple tarika first है, you have to do true or absolute intrusion, in which we just intrude the teeth, root apices of the anterior closer to the bony bases. Next comes relative intrusion. So what we do in relative intrusion, in this the incisors, the lower anteriors are kept at the same level while the mandible grows. So जब mandible grow होगा तो क्या होगा, posterior teeth will erupt automatically, leading to opening of the bite anteriorly. Okay, and third comes apparent intrusion. It is achieved by extrusion of the posterior teeth. So basically, relative and apparent intrusion are concept-wise similar thing, but theoretically it differs. How? So that in relative intrusion, it is due to the natural growth of the mandible, whereas apparent intrusion, there is no growth. We are forcefully extruding the posterior teeth so as to allow the bite to open in the anterior region. Last comes pseudo intrusion. So in pseudo intrusion, what we are doing, just labially tipping the anterior, that is we are proclining the anterior teeth so as to give us a effect or a pseudo effect that the bite has been opened. Okay, and next concept is reverse curve of P wire. So what are they used for? They are used for extrusion of posterior teeth. So what are reverse curve of P? So in exam they can give you this, or their short form as in, that is RCS wires. So RCS wires are used for extrusion of posterior teeth so as to open the bite anteriorly. Okay, and further important concept which they can ask is, what is the side effect of using excessive reverse curve of P wire? It can lead to proclination of anterior teeth as well. So we have to maintain that proclination or correct it, we can say. Okay, So this is the side effect of using reverse comb or RCS wire. Okay, so these are the concepts or exam important things related for your exam point of view. I hope it's clear until now. Next is methods of space closure. So what are the methods of space closure? So first of all, what is space closure? It's a simple concept. Space closure is required in the cases in which we go for extraction of teeth to correct a proclination or crowding, anything. So basically we are extracting, most common teeth which we extract in orthodontics is first premolars. So we extracted the first premolars. Now we want to retract the anteriors, that is the anterior from canine to canine, both upper and lower, so as to close that space. So there are two methods through which we can do. First is through sliding mechanics, which is known as friction based mechanics, and next is segmental mechanics or frictionless mechanics. So what is the difference between the two or how it is done? So if we go by literature or literary names by them, so segmental mechanics means we are dividing the wire into segments. So what are these segments basically? So there are two segments. One is the active segment, another is the passive segment. तो पैसिव सेगमेंट कौन होगा? पैसिव सेगमेंट वो होगा जो एंकरेज प्रोवाइड कर रहा है, जिसके थ्रू हम टीथ को रिट्रैक्ट कर रहे हैं. एंड इन दीज केसेस मोस्ट कॉमनली व्हाट कम्स इज द प्रीफायर, सेकेंड प्रीमोलर, द फर्स्ट मोलर एंड द सेकेंड मोलर. दीज आर द पैसिव, कंसिडर द पैसिव सेगमेंट. एंड एक्टिव सेगमेंट वो होगा जिसका हम रिट्रैक्शन कर रहे हैं, दैट इज द एंटीरियर टीथ. Okay, so that's why this active and passive can vary depending upon what kind of movement or what kind of mechanics we are trying to achieve. Okay, so these are the two segments in which the teeth are divided, and I have given you the example. So these segments are not connected by the same wire. The wire is divided into segments. There is not one single continuous wire which is running from active to passive segment. They are just connected. So they are made connected, the segments are connected to the same wire, but they are separated. The active and passive segment don't have any connection between them until now. So how does the retraction occur? The retraction occur with the help of loops. Okay, so retraction happens with the help of loops. I'll just write on the top, with the help of loops. Example of these loops can be T loop, Jessing springs, L loop, etc. So the retraction is happening with the help of these loops. The segment, the active segment, is pulled back. So there is no translation or movement of the segment on the wire. Okay, so what is happening is we pull the wire, and along with it the segment which is attached, the active segment, comes along with it. Okay, so that is why it is a frictionless mechanics. Why? Because there is no sliding of teeth on the wire, where the wire is pulled. Whereas when you come to sliding mechanics or friction based mechanics, the teeth translates or moves on the wire. Okay, so that is why it is known as friction based mechanics. Okay, so in sliding mechanics it will be completely opposite to segmental mechanics or frictionless. Here the teeth are connected by a same wire. Okay, and the force is applied through the help of a closed coil spring or a elastomer chain, anything, so as to pull those teeth back. Okay, so this is sliding mechanics and segmental mechanics. Okay, so next concept, if any, comes in biomechanics is lace back, tie back and bend. So what is lace back? So first of all, the concept of lace back was given by McLaughlin and Bennett. They are the one who give the MBT bracket, that is the third generation pre-adjusted edgewise appliance. Okay, so how it's given? It is given using a 0.010 inch stainless steel ligature wire, which extends from the distally banded molar to the canine bracket, and it is given, most important line is given before insertion and ligation of the arch wire. So in two forms they can ask you a question. One is most common with image based question or a theoretical. So अगर आपको image में पहचानना है, so you need to identify or remember that this wire, this ligature wire will be placed below the arch wire. So it will be a lace back. And next is why it's given. So it's given to restrict the canine from tipping forward during leveling and alignment. So if you remember from your Andrews 6 keys and how the evolution of pre-adjusted edgewise appliance occurred, so there is an inbuilt tip and torque inside the bracket. So when we place a round wire, what will happen? This canine will, due to the inbuilt tip, the canine will tip mesially forward. It is not because something which we did wrong, it is because of the inbuilt tipping or the inbuilt tip built into the pre-adjusted edgewise appliance or the bracket prescription. So this lace back is given so as to prevent this tipping forward. This ligature wire prevents it from happening during leveling and alignment. Okay, so this is the stage 1 of the treatment, leveling and alignment, and this lace back is given so as to prevent this tipping of the forward. Next, it is given placed below the arch wire. Next comes tie back. So there are two types of tie back, active and passive tie back. Okay, so the major difference between a tie back and a lace back, first of all, is although both are given by stainless steel ligature, here we have a presence of an elastic module. Okay, and जहाँ elastic word है, elastic module है, इसका मतलब वहाँ पर active force is being applied. Okay, next is it's given after the placement of arch wire. So there are two types of tie back. One is active tie back and next is passive tie back. So what is active tie back? Use for active space closure. So it has an elastic module like this. The elastic module can be placed either on the posterior teeth or the anterior teeth. It depends upon the choice of the operator, how it's convenient for it. And using a stainless steel ligature, it's tight. So the amount of stretching, जितना हम इस ligature को tight करेंगे, the elastic module stretches. Okay, and what will happen? जब ये stretch होगा, इसकी elasticity tendency से क्या होगा? It will try to come back to its original diameter, and with it will bring back the teeth along with it. So this is the function of active tie back. So similarly we have a passive tie back. So in passive tie back we don't have module, no module. So it's similar to a lace back. That just how it's similar, it just has a ligature wire in it. So how will you differentiate between a passive tie back and a lace back? So first of all, its use. So it is used to prevent space reopening after space closure. So जब ये space closure हो जाएगा, we just give a ligature tie on it so that the space does not open. And how will you identify? This is तो ये theoretically हो गया. How will you identify it? Image based. So this passive tie back is given over the wire. That is after the placement of the arch wire. Previously, the lace back was given before the insertion of the large wire. So अगर ligature wire below है तो it's lace back, above है it's a passive tie back. Okay, so theoretical point. So lace backs are normally continued throughout the leveling and aligning stage of arch wire sequence up to and including the rectangular hand stage, that is a heat activated nickel titanium wire. Thereafter, when we do the space closure on 1925 stainless steel wire. So now from here onwards, the same thing, the function which was done by lace back is now done by passive tieback. So now the passive tieback is the one which is providing the function which was done by lace. Okay. Next comes bend back. So what is bend back? So bend back is for anterior-posterior incisor control. Bend back is done posterior to the archwire to the distal terminal molar. Most distal terminal molar can be either 6 or 7, जिसके लास्ट मोलर से वायर एग्जिट करेगी. Posterior to that we just bend the wire distally. Why we do that? So as to provide proper anterior-posterior control over the anteriors, so as to prevent their flaring or proclination. Okay, so as to minimize forward tipping of the incisors. अगर हमने ये bend back नहीं किया तो what will happen? Arch wire के साथ साथ anteriors will also get flared out or proclined. So it is done to minimize the forward tipping of the incisors. So this was the another few important topic from biomechanics from where question can come. Next or the last comes these effects, that is the washboard, rowboat, wagon wheel and roller coaster effect. And what are these effects? So first is the roller coaster effect, जिसकी यहाँ image दी हुई है. So what happens is during space closure, अगर हम again जाए 4-4 extraction case है, we are retracting the anterior. What we apply? We apply force for retracting these anteriors. What happens? अगर हमने force ज़्यादा apply कर दी, what will happen? The posterior and the anterior teeth will bend. That is, the anterior teeth to tip and rotate distally, increasing the curve of speed. This curve of speed will deepen. It will be like a roller coaster, like this. Okay, and what will happen? It will have a tendency to increase the curve of speed and deepening the bite. Okay, and why it occurs? If the elastic force is greater than the leveling force of the arch wire, means हमने जो elastic force apply करी वो हमने पतली वायर या थिन वायर पे अप्लाई कर दी, इधर सर्कुलर वायर और लो डायमेंशन wire. So what happened? The force was more, the wire bent it. So because of that the wire bent it and it led to a deepening or increased curve of speed or deepening of the bite anteriorly. Okay, next comes the wagon wheel effect. So what is a wagon wheel effect? So as I told you, in pre-adjusted edgewise appliance, there is inbuilt tip and torque built into the bracket prescription. So what happens in similar thing is done for therefore anterior teeth as well. Okay, so what happens? Because of this inbuilt tip and torque, when we place a rectangular wire, the tip and torque the prescription gets expressed. So what will happen? If we imagine it three-dimensionally, torque is labiolingual movement and tipping is mesiodistal movement. So what will happen? Due to the labiolingual movement, the roots of the upper anterior teeth will go lingually, and because of the building of the tip as well, they will converge mesially. So the roots will go lingually and they will try to converge them as well as mesially as well. So they look like spokes of the wheel. If you have seen spokes of cart wheel. Okay, where the spokes represent the anterior teeth. So because of the expression of the prescription, there is expression of torque and tip for the central and lateral incisors. So the roots of the anterior teeth converge towards each other. So in what ratio? So for every 4 degree of torque, there is 1 degree of tipping or convergence of the roots of the central and the lateral incisors which occur. So this is known as wagon wheel effect. Okay. The third effect is the rowboat effect. So what is a rowboat effect? So if you remember what I mentioned in bend back, why we used to give bend back is this distal bending of the terminal wire. If we do not give it, what will happen? I just told you, the anterior teeth will procline. So this is the what will happen, this is known as rowboat effect. So imagine you sitting in a boat, we just rowing it through the help of rows. What will happen, we push the water backwards and where the water provides a forward pulling tendency to the boat so as to push it forward. Similar thing is happening here in this teeth. So it is the tendency of maxillary teeth to move forward during lingual crown torque of anterior. So what is happening, supposedly we place a wire. So as I told you, there is inbuilt prescription, so the teeth, the roots of the anterior teeth tend to go lingually and the crown goes laterally. So what will happen, crown se attached a wire, what will happen, it will tend to bring the posterior and teeth along with it forward like a robot. So we have just push the anteriors are getting proclined, and similarly because the wire is attached to the posterior teeth, they also tend to come forward. So this is known as rowboat effect because of the proclination tendency of the maxillary posterior teeth to move forward during lingual crown torque of anteriors. So this is known as rowboat effect. Next is a drawbridge effect. So what is it? It's the extraction of premolars. So if you remember, in older days the ships need to pass through water. So what they used to do, they used to lift the bridge like this so that ship can pass and the bridge goes collapse down so that the road transport can go over it. So similar thing is done here. So in this, the extraction of premolars are done to correct anterior open bite. So what happens, the bite is open. So imagine the two ends of the bridge like the two end, upper and lower anterior teeth, and this is the open bite here present. So what we did, we extracted the premolars and we retract these anterior teeth like this so as to close the bite. So these bridges are getting closed and get retracted like this so as to close the bite. So it's related to the extrusion of anterior teeth and increasing overbite by reducing the inclination of upper and lower incisors. Okay, so this is how the incisors are getting retracted like the two ends of the bridges and they are getting closed. So this is known as drawbridge. And lastly is the washboard effect. So washboard effect is seen in the lower anteriors mostly. It is due to the excessive labial or buccal movement of teeth into the cortical plates. Okay, so what happens if we sometimes give labial root torque, okay, and or lingual crown torque, what will happen, the roots will move out into the through the cortical plate, and if there is thinning or the cortical plate is thin or the gingiva is thin, what will happen, these roots will come out through this. So periodontally it is seen as fenestration or dehiscence of the roots. Okay, so this is known as washboard effect. Okay, so it may cause thinning of gingiva and partial see through the underlying root contour, giving it a washboard appearance, which occurs due to bone loss or root resorption as teeth contact the cortical bone, that is usually seen in the lower anteriors. So why is this term washboard given? It is a tool designed to wash clothes. So this is how a washboard looks like. This has certain rough margins like this, so similar kind of appearance is seen like this. If you took a CBCT, the roots are coming out through the cortical bone, so it looks like a washboard which is seen, or IOP is seen like this. So it is advised before doing such things in orthodontics, it is advised generally to take a CBCT or IOP so as to assess the thickening of the cortical plate so as to prevent this dehiscence or fenestration. Okay, so this completes our certain important concepts of application of biomechanics. I hope this session was informative for you. If anyone has any doubt, you can message me or contact us anytime. We'll be happy to help you out. So if anyone has doubt, can write in the comment section. I'll be happy to answer. Otherwise, I'll close the session now. Okay, so I'll close it now. Good evening, everyone. If any doubt, just write us or you can tag us anywhere.